This is Dr. Kraus with a quick video on how to use the root locus function from Python control module inside the Jupyter notebook. Most of my students are using the Jupyter notebook this semester for our dynamic systems and controls class, and that's worked out really well for us. And one of the nice things about doing that is we tend to use Matplotlib inline. I think that's nice in that it doesn't... Sorry, apparently I'm not typing and talking at the same time. One of the tricky parts is always, with the old school way that I would use IPython at a terminal, while also having a separate text editor, is trying to remember, okay, figure 1 shows me what again, figure 2 shows me what again. And so the inline allows me to just kind of put the figures right with the code wherever they go, and I can put some markdown text around it and just kind of write a little mini report, and so it just makes it easier to keep track of my figures, and so inline is really, really great. Where it kind of lets us down a little bit, and maybe they fixed this, or maybe there's a workaround that I'm just not aware of, but if I say I want to show a root locus, it does that really well, and that is the locus, and I can see that I've got a pole at -1, and I've got a pole at the origin, and they stay on the real axis and come together and break away, and so that all looks right. But if I wanted to design a controller that put the poles right here, I'd like to be able to click on that and have it tell me what is the K value associated with that point, and then what pole would I be choosing, and so on and so forth. And that is, in fact, what the root locus function is supposed to do if print gain, I think is the option, is true. And you could come over here and type help control. Apparently I can't type anything today. And so it's automatically going to return the root matrix and the K list, but it also will generate a plot by default. And by default, it will print the gain that corresponds with any point you click on, but only if it's an interactive plot. And this is a non-interactive plot. And so the key thing is to come up here and delete this inline, and then do a kernel.restart and run all. And now it's still using them, and so I've still got this %matplotlib that does nice things and causes my plots to be in a separate graphics thread and that sort of thing. But the plot is now in a separate window, which I would normally consider to be not quite as convenient. But what it's going to let me do, although it acts like it's mad at me, did that in fact work? Yeah. So now, I don't know what that error message is, it's some kind of warning, but if I click on a point on the plot, it tells me that I clicked at this point essentially on the real axis, and here's the corresponding K value, and at that point my damping would be 1. And if I picked this point, I'm talking about a gain of 42, and I would have a very small damping, because if you're looking really closely, my imaginary axis and my real axes are very different spans, and so I'd have to zoom in and click right there to get something more like a damping of 0.1 or even 0.3 with a gain in the neighborhood of 2, and that would be my pole location. So all that to say, the key to getting the clicking on the root locus to give me the gain and the pole location is to have %matplotlib but not have the word inline, and then I get this other window that pops up that apparently whenever I click away from the plot, it gives me a really bad answer. So yeah, no inline, click on the plot. Here is the K value associated with the point that I've chosen. This would be the damping coefficient associated with the point that I've chosen, and this is the nearest pole to where I've clicked. Thanks.